All right, everyone, this meeting is being recorded. For the benefit of people who are watching the recording, the slides are at tinyurl.com/introcpslides1. And what I said at the beginning is pretty basic. Oh, join the Discord. All right, so this is the team. We're all here, I think, and this is like what our track's going to be about. It's going to be Thursdays from 7 to 9, so this time every week, or almost every week this quarter. I think we'll have 6 main workshops and a mini contest. Topics we're going to cover are math, arrays, sorting, binary search, and dynamic programming in that order. Today is just an introduction. We won't formally be doing any of those things. Where this intro to CP track sort of fits in with like the rest of ICPC's workshops and the world of competitive programming in general is it's a place to get started. So we're hoping that people will do our intro to CP, which is really part of this beginner track thing, but we have a harder beginner track that will run in the winter and spring. We have a programming contest called Code Sprint LA, which will run in the probably the late spring. And we recommend that as like a good first time doing like a serious programming competition. Beyond that, there's ICPC itself. We have tryouts and such. There's advanced track for hard problems. There's other contests, Google Code Jam, Code Forces, I don't know, company contests where you might win an interview or something. Or you can just take what you've learned from competitive programming and go through your life and your career being a better programmer and problem solver. So many options. So why should you do it now, though? The reason that we do it is because we think it's fun. There's this skill-based element, and we like hang out with each other. So I guess if you come to our meetings, it'll be social. And like I said before, you can win things like small amounts of money or interviews. So I guess those 4 things together like make it a sort of esport, and there are even Twitch streams devoted to competitive programming. I don't think this is a super common occurrence, but like this does happen. There are famous competitive programmers that people like are fans of and stuff. I think there's a lot of tourist fans in our club. Anyway, so yeah, the programming competitions that you can try. There's ICPC regionals. There's Code Sprint LA. If people want more details on those things, I kind of want to like move on to the main content of our workshop now, but please ask questions after. Both of those things are like run by us, or at least like the sending of the team to regionals is run by us. So you should ask us. There's also Code Forces, other websites, and company contests like I mentioned before. All right, let's get started. So first, you're going to need your programming tools. And the number one most important programming tool is pencil and paper. I'm not kidding. You will save so much time in the long run, especially on hard problems, if you can work it out with pencil and paper, or like if you don't like pencils and paper, like pens and blackboards or something. That sounds like a terrible combination, but like, you know what I mean? Like working out what you want to do before you code is super important. And that's just like, sorry, I'd be distracted by the chat a little bit. What was I? Yes, use pencil and paper. Don't just jump into code. You'll see this later. Okay. In terms of what programming language to use, we recommend C++. However, like for the reasons above, and especially because like it's what you'll learn in CS31 and CS32 if you're taking those classes. So C++ is just like, it's pretty much the fastest language that's like feasible to code in. Assembly, you probably aren't going to want to write assembly for your competitive programming. So other alternatives though that people use are Java and Python. If you know either of those languages, all the problems that we do in this workshop can be solved using those, except maybe some of them will be harder to do in Python because Python's slow. And as for what setup you should use, we all use VS Code as our editor. And if you're on Windows, we recommend using Ubuntu on Windows or Windows Subsystem for Linux, either version 1 or version 2, as a way to get the G++ C++ compiler, and just as a way to get all of like the development tools that you need. People who are advanced use GDB for competitive programming. So like, I don't know, that's also something that you can get from having Windows Ubuntu. But for today, if you don't have a C++ setup ready, then you can go to Replit, which is a pretty cool website that basically gives you a Linux computer for free. So here are, there's a question, VS Code is just a text editor? Yes, VS Code is just a text editor, which is why you also need to have some kind of install of the C++ compiler. So we recommend G++ both on any platform pretty much, but you could also use Xcode. There's a slight issue with Xcode and some of our own templates that we give you that we'll describe later. But anyway, yeah. So for today, if you don't have a C++ setup ready, or you want to check out Replit, which Replit's pretty cool. I didn't appreciate it before. Then like, here are the links, repl.it/languages/put your language, and you will get this nice, pretty much like an IDE plus a terminal, which is like fantastic. Only downside is it's kind of slow, but that's okay because, well, like when you submit your program to be judged, as I'll talk about later, it's not going to run on Replit. Okay, cool. So I hope everyone who wants to has opened the appropriate Replit thing. And now let's talk about the contest platform that we're going to use for basically this whole workshop. It's called Caddis, the cutest contest platform. So everyone go to open.caddis.com/register, make an account, and then tell us your username at this tiny URL, which I hope works. Yeah, I'm gonna give like, say, 4 minutes. So until 7:21. Yes. And while we're waiting, let's say you already have a Caddis account or you finished, we'll have a Zoom poll for you as well. We want to like just get an idea of our attendees' backgrounds. Oops. Sorry. All right, I'm not seeing anything in the chat, so hopefully no issues there. Oops. I hope that. Oh, there's nothing sensitive there, but I'll try not to let the screen get cluttered. All right, a couple more minutes. Yeah, let me see. Oh yeah. So there's a question about like, what is your Caddis username? Yeah. You're welcome. Yeah, you feel free to private message any of the officers with your username if you want to tell us. This poll is also like completely optional if for some reason you don't want to tell us your Caddis username. Like, I mean, I guess we may use this list to decide who, like, which Caddis users can access the mini contest, but all of our workshop things will be accessible to any Caddis user. So, yeah. Okay. Cool. Thank you, everyone. So I'm seeing that most people have filled out the Zoom poll. I'm assuming that means they figured out the Caddis thing. Hold on, we have 62 responses on Caddis. Yeah, this whole workshop won't be at a particularly fast pace, we hope. So don't worry if you're on something that I've moved past, because you'll probably have time to catch up while I talk. All right. Cool. So now it's time to join your first Caddis contest. So go to this tiny URL. It's intro CP1 examples, not like the number comes first. And click join the contest. It'll be this little gray button on the right. Yeah. And please let us know if there's any issues in the chat. I'll give you another minute for that. Everyone's saying they're a spectator. Interesting. Okay. Give me a second. All right. Well, I can see that no one is joined. That is annoying. So are you all not able to join the? Let's see.
Yeah, there's no join contest button.
There's no join contest button. That's bad. Okay.
I'm able to submit solution code though. Is that normal?
That's fine. I think. Okay. I see what I messed up. Yeah. All right. Sorry, y'all. I think please just use this link anyway to get the links to the problems. And you won't be able to see like your rank in the contest versus other people, which is like not how we set it up anyway. Yeah. If you can see the contest as a spectator, that's fine. Yeah. Okay. So, yeah, this will be a lonely contest with no one in it. That's my bad. The contest that we have later should not have this issue. Okay, cool. All right. So click on problem A, hello world. You should get a very basic looking problem screen. And it shows all of the parts of a problem on Caddis, which are the problem statement, the description of input and output, sample test cases, although unfortunately Hello World does not have any sample test cases. You'll see those in all of the future problems. And then this like submit button on the right side. So that is probably like the part of the website that you'll need to interact with the most. So click on the submit button just to see what it looks like. You should see a screen like this. And you can upload files from your computer, or oops, okay, I guess that's not here. I guess another thing you can do is click on switch to editor, which will let you paste code or type it if you're brave. Not recommended. Typically leads to compile errors. So yeah, I guess that's the quick tour of Caddis. When you do submit code, you'll get something that looks like this. So if you want, you can try to submit something for Hello World. Python might be a good language for this one if you know Python. And if not, just like, don't worry, you'll see this screen soon enough. It shows you all the test cases that you passed. So each test case is like an input and then an output that your program should give, and the output of your program is compared to that output. And if it is the same, then you get a green check mark. If it's not, then you'll get some kind of X. If your program times out, you'll also have a problem. So here are all the different categories of errors. Well, okay, so there's AC, all correct, which is what you want. It's not an error. But then the most common ones that you'll see are WA for wrong answer and TLE for time limit exceeded. And if you like listen to competitive programming people talk, they'll be talking about their TLEs and WAs all the time. So these other ones are more rare, but yeah. I can't see the chat anymore, so officers, please, like, if there's something like that I should answer from the chat, just like unmute and ask me, and then I'll answer it. Okay. So, in summary, the way Caddis works is you view the problem, you click submit. I guess ideally you code your solution, you click submit, you submit your solution, and then you see what the judgment is. All right, cool. So, let's get into solving some actual problems. Are there any questions before we start? on. Okay, so our first problem is called factor. Yeah, so there are two sets of problems that we're going to do in this workshop. There's the examples, which we're going to talk about, and then there's the contest, which starts in 30 minutes and which you should actually be able to join. I checked to make sure that it was open. That, like, if you found the link from like skipping to the last slide because you're that kind of person, then yeah, you're welcome to join it. But that's not where these problems are. These problems are at the other contest link, which unfortunately, sorry, you can't join. It's spectator only, but you can still submit to the problems, and that's all you need. We don't really want to be ranking you on like how fast you submit for the like example problems. Okay. So these IO templates I'll talk about in a second, but you might want to open that GitHub link anyway. And the problem is called factor. It should be problem B in the contest. So here's what you want to do. Read the problem statement, read the IO, try to understand the problem. This problem does take a little bit of thinking. So it's not like if you read it really fast, like there's a pretty high chance that you'll just not understand the problem in the first place. And then get wrong answer because you didn't understand the problem. So do that. When you're writing your solution, what you submit to Caddis needs to be a complete program that reads from standard input and writes the standard output. So on LeetCode, typically you just fill in the body of a function. On Caddis, you need to submit like something which would compile to, or in the case of Python program, just like is a standalone executable. All right, that sounds like pretty scary. Sounds like a lot of computer science. Maybe, it's just like week 2 and you're learning about for loops in CS31. It's like that sounds pretty scary. All right, so because of this, we've decided to provide everyone with IO templates that will sort of convert the problems back to the built-in the body of a function LeetCode format, although we highly encourage you to check out what the IO in the IO templates is actually doing and learn from that, because that is what you will have to do on your own programming contests. So this link should take you to a GitHub repo, which is for this workshop track. And there you will find templates for all of the problems that we're going to be doing today. So I guess you can peek at what the contest problems are. But please don't. Okay. I'm assuming any issues with this, please say something in the chat. So like if you look at one of the most of the templates, they'll have this line that says hashtag include bit/stdc++.h. This is a nice trick for including all of the standard library headers. But we've found that it doesn't work with Xcode. So if you're on a Mac and you were planning to use Xcode, you have two options. Number one, if you go to the GitHub repository and you go to the top level of the GitHub repo, then you will see, or follow the link in the chat, you will see a kind of generic template that does work on Mac. You can just like copy paste all of the includes and stuff on top of whatever you're already using. Or alternatively, you could just use Replit, which should be totally sufficient for this workshop. So yeah, anyway. If anyone runs into a weird compile bug on their own computer, this isn't a problem with Caddis. This is just a problem with people's local computers. You run into weird compile bugs, ask in the chat, and one of our officers will help you. All right. So now that you're ready to code your first solution, or maybe you haven't got there yet, which is good probably because it takes a little bit of thinking to do this problem. The idea that we were hoping for was people would get templates from the GitHub, paste them in Replit, fill in their code, run in Replit. So like, I guess click the run button that comes up at the top. And then the way these contest solutions are set up, they're programs which you can run from the command line and take an input, output, and output. So you will like want to look over to the command line on the right side of Replit, type in or paste whatever input you want to put in, and then look at the output, which should be printed on the next line, and see if it is what you're expecting. All right, so I'm assuming people are working on Factor now. Yeah, I guess that is perhaps another downside of people not being able to actually join the contest, is we can't track people's progress, which would have been fantastic. Anyway, but oh yeah, okay. So once you're ready to submit your solution, then we went through this before, but you want to click submit on the right side in Caddis. And Backdoor is problem B in the contest, which is at intro CP, like tinyurl.com/intro CP1 examples. Maybe someone could post a link in the chat again. And click submit, choose what language that you're submitting in. Otherwise, you might get a compile error because what you submitted was not valid ADA. And then like we recommend this like switch to editor, paste your code approach if you're copying pasting from Replit. So I see a question about some string processing in C++. My answer to that would be, if you are worried about this, just use our IO template, which will read in the numbers for you, and maybe look at how it works to see how it does that. Yeah. Okay, so I'm going to give everyone like a little bit more to work on the problem, and then show some hint, and then we'll move on to the next problem. Let me see. Oops. Sorry. If you just got here, we're working on a problem called factor on caddis. Yeah. Here. Yeah, click the link in the chat, and we're doing problem B right now. Okay, I think it's been some time to work. I'm gonna. These are some pretty basic hints, which are like, I think sample input 3 is like good for thinking about this. It's like, can you explain sample input 3? Yeah, so the wording of the question, it is slightly ambiguous. I am not a huge fan of the wording of this question. However, I do think it is a good, like, introduction to like what you will be dealing with competitive programming. So I highly recommend, again, looking at these samples and seeing if you can explain the samples. So yeah, all right, I'll work through this test case. Sample input 3, so like 10 articles, impact factor 10, why 91? Well, we're trying to reach impact factor 10, and whatever number of articles, or sorry, whatever number of citations we have is going to get divided by the number of articles, and then rounded up in some, like, which the rounding up, I think, is somewhat ambiguously stated. Like, do you round up like you normally round up, like 5.5 would round to 6, but 5.4 rounds to 5? Well, let's look at sample input and output 3. So 10 articles, trying to get to impact factor 10, and it says 91. 91 divided by 10 is 9.1. So their definition of round up must be very generous, because like 9.1, there's like basically only one definition of round up, for which 9.1 rounds up to 10, and that is the ceiling, or take the least integer greater than what you're given. Or in simpler words, like round up if there's anything left over after the decimal. So notice that the output's not 90. That's because 90 divided by 10 equals 9, which is less than our target impact factor of 10. But 91 goes above that, so it gets rounded up to 10. Please ask in the chat if there's any more questions. Right, so there's a question about copying code from Replit to caddis. So we covered that already, but maybe a little too quickly. So when you submit, click switch to editor. and then you'll be given like a box where you can paste your code. So just using Control C, Control V, and then finally submit using this submit button at the bottom right. Yeah, please ask in chat, like I was saying, if there's any more questions. We're also going to move on to the solution in like a minute or two. Yeah. Okay. Matthew, maybe you could ping one of the direct message one of the other officers who should be listed as a co-host, and they can help you out with your individual case. Yeah. Not me though, because I'm talking. Okay, it's been a couple minutes. I'm going to move on. If you're still having issues, please, if you're having some if you have a general question, please ask in the chat generally. If you have a specific question, it would probably be better to message an officer who can then help you with that. All right. Cool. So, as for how to solve this problem, hopefully thinking about the example test cases led you to this. But the idea is basically, let's say there's a certain number of articles. Well, whatever number of citations we have is going to get divided by that number of articles. So we can imagine however many citations we have is getting broken up into chunks, each the size of the number of articles. So here I just worked through another example, which is 3 articles, and we're trying to get impact factor 6. So because of this rounding up rule, if we have 1 citation, even though that gives us a ratio of citations to articles of 1/3, it gets rounded up to impact factor 1. However, we go all the way to 3 citations, still only impact factor 1. But if we go 1 more, then we get impact factor 2. So that suggests that let's say we're trying to get to impact factor 6. Well, 6 minus 1 is 5. If we do 5 times 3 citations, we will still get impact factor 5. But that's the biggest number for which that happens. If we do 5 times 3 plus 1 citations, then we divide by 3. We cannot fit all the citations into 5 blocks of size 3. There has to be some left over, which means that the quotient will round up to 6. And this lets you write down a formula. So if you remember what I just did, I took the number of articles, multiplied it by our target impact factor minus 1, because that gives us our upper bound on the most citations we could have to get impact factor minus 1. And then we want to go 1 beyond that, and that'll give us the least number of citations we could have to reach impact factor, the actual thing that we want. So if X is our desired impact factor, A is the number of articles, then the answer is 1 plus X minus 1 times A. And it's important to check corner cases. In this case, actually, this works for every input value. You probably want to think through separately, oh, what if it's impact factor 1? If it's impact factor 1, you only need 1 citation. Does this formula output 1 when X equals 1? no matter what a is. Well, 1 plus 1 minus 1 times a is 1 plus 0 times a, which is just 1 all the time. Yeah. So I'm going to, or wait, shoot. You guys should see a poll about the problem. So you see a poll about the problem factor. If you have any questions, ask in the chat. But we will next be moving on to this problem C, boss battle. And I'm going to actually hand over the screen to our officer, Rishi Sankar, who will be presenting this one. Okay.
Okay. Can you see my screen, Jacob?
Yeah.
Cool. All right. So this is going to be the second problem that we do today, and I lost the chat. Give me a sec. Could someone send like the problem in the chat? I don't know. I can't find it.
Do you want the problem, like just a direct link to the problem on Caddis?
Yeah.
Okay.
Yeah, I don't know. The chat seems to have disappeared when I screen shared. Anyway, yeah, so I guess we can start by just, you guys can start by reading the problem and then I'll talk through it in a few minutes. Okay. I hope everyone's gotten to read the problem. And yes, I'll just really quickly explain the n equals 4 case, which is the one that's in the problem statement, just to make sure that the problem's clear for everyone. And so essentially the idea of the problem is that you alternate between your turn and then the boss's turn. And on your turn, you can throw a bomb at one of the pillars, and the bomb will explode and essentially blast 3 different pillars that are adjacent. And then on the boss's turn, the boss can move to any one adjacent pillar. And your goal is to kill the boss. So in the case of 4 pillars, you start by choosing any of the 4 pillars to bomb. And when you place the bomb, the middle one explodes as well as the 2 adjacent ones to it. And then after that, your goal is to make sure no matter where the boss started, that the boss is defeated. And so you can assume that the boss was not defeated by the first blast, and it's in the last position, which is the white one. And then after your turn, it's the boss's move. And on the boss's move, you know they're in this white position, and they can move to any position that's adjacent. So, or they can stay in the same place. So they can either stay here, or they can move to one of the adjacent 2 spots, which are these 2. So after the boss moves, they can't be here, but they could be in any of these 3 positions. And then finally, on your second turn, you can place a second bomb over here, and then that covers the last 3 positions, and you're guaranteed that the boss is killed. So because of that, with the case of 4 pillars, 2 bombs is enough to kill the boss. That made sense. That didn't, then you can ask in the chat. But otherwise, I'll give you guys another 5 or 10 minutes or so to work on the problem. There's a question in the chat, but can you resubmit if you've already submitted? And yeah, you can. You can resubmit as many times as you want. Yeah, so about the question in the chat about after a pillar being destroyed. So the problem says that the pillars are actually indestructible. So the pillars aren't, essentially once the bomb goes off, all that means is that the boss can't have been in that position because you're assuming that the boss is in the optimal position so that the boss doesn't die when you hit the bomb. So what that means is when you throw a bomb at any location, then the 2 adjacent pillars, which are the ones directly counterclockwise and directly clockwise, also get exploded. And so if the boss is in any of those 3 positions, then the boss dies. But if the boss is in any other position, then they don't die, but they can still move to one of the positions that had previously been exploded. And I also want to give a couple hints on the problem now that you guys have been working on it for a few minutes. The first is that the second sample test case might be hard to explain, but in general, it's a good idea to try a couple other test cases. I showed the test case for n equals 4. You can also try things like n equals 5, n equals 6. And yeah, so keep trying n equals 5, 6, 7, and so on, and see if you can find a pattern. All right, I'll give maybe one more minute and then go through the solution. Is the recording good? Cool. Okay, so I hope everyone got a chance to work on it. If you didn't finish, that's okay. You'll also have time after the workshop. You can ask questions about it or do the contest problems. And yeah, so this is the case for n equals 6 pillars. And essentially, the first part of the n equals 6 case is really similar to the n equals 4 case. So you start by choosing any pillar to explode, and that clears the boss from being in 3 of the locations. And then it's the boss's turn. On the boss's turn, they can move to any adjacent location or stay in the same position. So if they were in any of these 3 positions, they could move again to any of these 3 positions, or if they were in this one, they could move here, or if they were in this one, they could move here. So after the boss moves, there's 5 positions where the boss could be, and 1 position that's 100% clear. And then on your second turn, you can place a bomb over here, which is 1 away from the previously cleared position. And now you've essentially cleared 4 positions, and the boss can only be in 2 of the remaining positions. And then on the boss's turn, they can again move anywhere. They can move anywhere adjacent. So they can move here, or they can move here from these 2 positions. And so once again, the boss has, I guess, has 4 positions where they can be. So the pattern here is that on your turn, you eliminate the boss from being in 3 different places. And then on the boss's turn, they add 2 more positions to the places where they can be. So you cut out 3 of the positions, and then the boss adds 2 more back. And so this is kind of, yeah, so for the 6th case, this is the full diagram. So essentially the first time you cut out 3, then they add 2 back, then you cut out another 3, and now you're at 4, and it's 2, then 5, then 3, then 6. So it takes 4 bombs to guarantee the boss is killed. And so this sort of oscillation is sort of the key to this problem. So essentially, on your turn, you can eliminate 3 positions, then it goes down by 2 when the boss moves, then you can eliminate another 3, then it goes down by 2 again. And so essentially it sort of oscillates like this, but the goal of the problem is essentially to find the first position where a certain amount of positions are eliminated. So for the case of n equals 6, if you look at the first point where that's reached, that's over here. For 5, it's here. For 4, it's here. And so it all tends to follow this one line, which is y equals x plus 2. And so what that means is that you can essentially find the answer by just subtracting 2 from your input n. So for anything with more than 3 pillars, the answer is just n minus 2. And so the entire code used to solve this problem actually ends up being super, super simple. It's just if n is greater than or equal to 3, then you print out n minus 2. And otherwise, you just print out 1, because if it's 1 or 2 pillars, you only need 1 bomb to clear every single position. Yeah, so that's the general solution to this. Didn't make sense, or if you have any questions about it, you can message me after. But yeah, that's pretty much it. Yeah, Tony, do you want to screen share? Oh, wait, yeah, Tony, before you start, we're going to do a poll again. This one will be the same poll as last time, just getting feedback about this problem. Yeah, so you could fill it out, that'd be great.
Okay. While you guys are voting, I'm just going to continue. So for the next question, before we head into the next question, we need to take a look at the data structure called array. If you are experienced with computer science, you might be really familiar with this data structure already. If not, don't worry, I'll try to explain it to you as clear as I can. So basically, an array is a way to store a sequence of data. Say if you have one number, you can store it in a variable. But if you have 5 numbers that are related to each other, you might want to store them together. And in this case, you would use an array. So if A, for example, if A is an array of length n, you can get the element at index I with this syntax, A square bracket I. And then A0 is the first element, while A n minus 1 is the last element. For example, if you have a value storing at position 4, it's actually the 5th element of the array. And if you want to access it, you would write A square bracket 4. But for the purposes of competitive programming, we recommend you use the vector class instead of raw C++ arrays. You'll learn about arrays in C++ in CS31. But vectors are basically a more well-rounded array. Using vectors, you can avoid some of the nasty bugs you might not understand until you learn more about C++. So here's how to declare a vector of integers of length 7 with each element initialized to -1. So basically, if you write this in your code, you would have a vector of integers called people. And then in this vector, there would be 7 negative ones. And then you would access them each of them individually by using the square bracket notation. People, square bracket 0, people, square bracket 1, and so on and so forth. And if you want to store another type of data, you could replace int with, say, char, bool, or string. And then here's more about vectors. To declare a vector, you do vector int vec. And then the first parameter tells the vector how long the vector you want the vector to be. And then the 0 tells the vector what the initial value of each position is. And here's the initialized vector. And similarly, you can also initialize the vector by telling C++ what values you want to plug into the vector. And here you would get a vector like this. And then here are some operations you can do on the vector. You can do vec.pushback 1, and this would append a 1 at the end of the vector. Similarly, you can do popback to remove that 1 from the vector. And then again, to access the vector, you would just do vec square bracket I. Now we can take a look at the third contest problem, lost lineup. You can find the IO template at this link. And yeah, this problem is a little bit more complicated than the earlier two. So take your time to think about it. I'll give you guys a few hints a few minutes later. If you have any questions, feel free to ask in the chat. Okay. So essentially, Jimmy and his friends want to find out the original positions of themselves, but they don't remember their original indexes or their original positions. They only remember the distance between, like their distance between Jimmy and themselves. So the first hint, So the first hint would be try to work through the example input 2 and write it down on paper, see if you can figure out why the answer is 1, 4, 2, 3 in this case. And another hint would be to think about if there are k people between Jimmy and the person, what's the person's original position in the line? So let's take a look at this example. Let's say because Jimmy is always at the front of the lineup, so Jimmy is always 1. And let's say this person, colored in blue, wants to know where his or her position is. He remembers that there are 4 people between Jimmy and himself, so his position would be 1 plus 4 plus 1, which would be 4 plus 2, right? If this person wants to know what his original position was, he would be 1. It would be 1 plus 3 people in the middle plus 1, and that would be 5. And to implement this solution, we can create a vector people of length n. And then we can use this vector to store the current position P of the person. Let's say, let's take a look at the graph on the left, the diagram on the left. This would be the input you get from the question 1, 2, and 0. And because Jimmy is always at the front of the line, so I just put Jimmy in the line to make it easier to explain. Now, in this line, if the first person wants to know where his original position was, let's call this first person Tim. Okay, if Tim wants to know where his original position was, he would tell us that there was 1 person between Jimmy and Tim, and there was 1 person between Jimmy and Tim So if Jimmy's originally at the front of the line, then Tim would be at this position, right? At position 2, because there's one person between them. So we put the current position 2 at here in the people array. Similarly, if the third person wants to know where his original position was, and he recalled that there were 2 people between Jimmy and himself, so we would put him at because there were 2 people between Jimmy and himself, so we would put him at position 3, and then we put his current position in as the value. So you can probably see a pattern here now. It would be people k plus 1 equals p, where k is the number of people between Jimmy and this person, and p would be their current position. In this case, it would be people 2 plus 1 equals 3. And let's go to the next person. The next person, remember that there's nobody between this person, between himself and Jimmy. So we would put the next person at position 1, or the second position in the original line. And his current position is 4. So the value we fill in will be 4. And now we have the original array, which is 1, 4, 2, 3. And that's how you solve this problem. Now, I'm just gonna start the poll again. And do you guys have any questions? Feel free to type it in the chat. And while you guys are voting for the poll, I have some general tips for you guys. And here are some tips for all situations when you're doing a competitive programming problem, when you're doing a competitive programming contest. The first one is to always test your code before you submit the code. You can run it on repo.it. You can run it on your local terminal, but don't submit it immediately after writing your code, because there might be a really, really silly mistake you made in the program that you didn't realize. And then once you submit the code, you will be penalized for it. But if you run it at once on your local terminal, you will be able to figure it out really easily, and you don't want to make those mistakes. The second tip is to always work through the examples, because the examples, even though they seem trivial sometimes, but they really give you some insightful hints when you feel that the question is a little bit hard. And also, you want to work through the examples because sometimes you might have an algorithm in your mind, but it might not work. So if you don't work through the example, if you work through the example, you might be able to find out that your code doesn't work. But so it saves your time so that you don't have to write out your code, type in the example, and then find out that your code doesn't actually work. Now you have to recode it again, which is not efficient in a competitive programming setting. And then the third point is kind of similar to the second one, and it is that you want to solve the problem on paper before you write the code. And this is just to save time in case you make some mistakes. And then the final tip is to come to Intro CP session 2 for more tips. If you feel like this workshop it's a little bit easy on the easy side, don't worry. There will be as the quarter progresses, our questions will become more and more interesting. And then if you find this workshop to be on the hard side, feel free to reach out for help. And also, as you get more practice in, you will get more and more comfortable with these questions. So let's see. Yeah, and now I think it's contest time. Oh, it's feedback time. So does anyone have any question, comments, or concern? Feel free to write it in the feedback form right here. I'll type it in the chat. Jacob, should we do the contest now?
Yeah, let's do the contest.
Okay.
Contest started 20 minutes ago, but that's okay. This one you should actually be able to join. So if you go to that link, and then I guess follow the slides on how to join a contest that unfortunately didn't work for the in-class session, you should be able to join that contest. You'll see a leaderboard, and you will see problems. I think there's 5 problems. They're ordered from easier to harder, although that order may not be perfect. So if you're like stuck on the first problem, maybe try the second one. Enjoy. All right, I'm going to end the recording, like perma end. So thanks for joining us if you were watching this video.